All right, so we want to display the load distribution pattern. So we right click and go to display. Then under the display, if you go to loads, you will see load distribution region. If you click on it and you apply, all right, then nothing will show anyway because we have not actually run the analysis for the load distribution. So we just apply it, then we okay this. Now to activate this thing now, we go to the load and no, we go to analysis, then we go to generation of computational model. We click on it and allow it to run. All right. You allow it to run. Now, can you check something out? Let me rotate the structure. I want you to notice something now. You can see that the load distribution is one way because the loading is not moving up, it's just sideways. This shows that the loadings are being applied to the columns.
To the columns, yes.
The same thing at the rooftop. The loadings are being applied to the
rafters.
The rafters. Now let me do something. I'm going to change this cladding to maybe two-way. You see the difference now. Change it to two-way. Now let's run it again. Analysis and this. Can you see the difference?
Okay.
Now, if you go with this, we see that part of the loadings will be applied to the bracings.
To the bracings, yes.
To the bracings. And we don't want any loading to be applied to the bracings. We want every load to go to the columns. So this is why you cannot go for this two-way option. So it has to be one-way X so that the loading can go to the columns. Now I will run it again for you to see. Analysis, generation of computational model. Can you see it now?
Yeah.
So anytime you model your cladding, you have to adjust the load path, the load distribution path, so that you don't apply load to members you are not supposed to apply load to. So it's very important. All right, so now we can deactivate the load distribution region now. So we go back to display. Then under the load, we click on this, then apply. All right, now we need to analyze this model. Then we just, very simple, we go to analysis, then we go to calculation, then it will run automatically. Finish, we are done. Or you can click from here, calculations. Once you click on calculations, it will run automatically. All right, so if you check this green button here, you see that it's showing results, then FEM available. This is telling you that your analysis is up to date. When it is yellow, it means your analysis is not up to date.
Okay.
Now, after the analysis, we need to design the members. That's the next thing to do. We need to design because, I told you something from the beginning of this class. All these sections that you selected, they are assumed. So it is the software that will now tell you whether the sections are sufficient or not. So let's start with the column first. This is how to go about it. You click on this drop-down menu. Or before we do that, it might interest you maybe to see the shear force diagram and all the bending moment diagram. So let's click on one of your rafters. I will quickly show you that before we proceed. I will click on this rafter, this one. Then I'll go to a new window. Okay, I can rotate it a little, like this. Then to see the bending moments diagram, you can go to results, then diagrams for bars. Then you can click on the MY, then you apply. You can't see any value yet. So to see the values, you can go to parameters, click on text. You can differentiate between the positive bending moment and the negative bending moment by clicking on differentiated. And if you don't want to differentiate it, you can click on undifferentiated. So both negative and the positive side will have the same color. But if you want to differentiate, you click on differentiated. Also, if you want it to be filled up, you click on filled, then you apply. Now you can see the value of the bending moment here is about 30.85 at the negative side. Then at the positive side, we have 23.37 here. And here we have, okay, we also have 23.37.
The same value.
The same value. Yeah, I think normally it should be the same value because they have the same
span.
The same span, the same loading, everything is the same. So this allows you to check your bending moments. All right, so you can even use these values to check manually to see if maybe the member that would, the section that will work, or maybe sometimes some people might consult you and say, okay, please help us analyze this member. It is not every client that will be interested in structural details. Some people will consult you and say they just want you to analyze the structure for them to see if the members, the sections they have is sufficient or not.
Adequate.
Whether it is adequate. So it's not everything or every time we'll be generating details. All right, so this is how you get your bending moments. Yeah, very simple. All right, so you can also increase the size of this bending moment diagram by clicking on this plus. Like if I double click twice now, 1, 2, and I apply. Sorry, apply. It will increase in size. 1, 2, apply. Then if I want to reduce it, I can just click on minus, apply, like that. All right, so I will uncheck this, then I will apply, then I'll close this, then I'll exit this window. All right, so for the design now, you go to under this area, instead of geometry now, you go to steel design, then you go to steel/aluminum design. All right, so you have a new window here. I want you to pay a good attention here, even though I'm recording it, but still pay attention because it might confuse you. If you don't pay attention, it might confuse you while trying to do it on your own. All right, so now this is how we do the design. It's very simple. You click on this steel aluminum member type. Right? Under it, we have the default settings for columns and beams. Okay. Now, if you double click on the column, these are the default settings for the columns. All right. Now, later on, we might explore this, but I wanted to get something first. This is the column settings. So what we're going to do is that we're going to place all these columns under this settings. It's just like match property in AutoCAD. When you want to match property, you click on the what is it called? object that you want to
its properties to be matched.
You click on the result you are looking for first. Then you now click on the object. So the same way you click on this column like this, then under these lines and bars, you just click inside this box. Then after that, you come to your model, click on one of the columns, right click and select similar by cross section. All the columns will be selected, right? Once the columns are selected, the bar numbers will be displayed here. You just need to left click inside this box once. Once you left click, the bars will be, the bar numbers will be highlighted. After that, you Control C for your keyboard, Control C. Then you come to this box and left click. You don't even need to paste it. Once you left click, the same bar numbers will be pasted here. Is it clear?
Yeah.
Is it clear?
It's clear, yeah.
Sorry, when the time is over, please try and join using the same link again.
Okay.
All right, so now I have the bar numbers there, then I have the column selected. Once I click on apply, the settings will be transferred to all the columns. Clear?
Yeah.
All right, good. So we go to beams now. So for the beam, you click inside this area again. Then for the beam, that's a rafters, because the rafters they are more or less like the beams. So you click on one, right click and select similar by cross section. Then you click this box and click here again. Then you have everything pasted here. Then you click on apply. Then that means you have transferred the settings to all the rafters. Is that clear?
Yeah.
You can do the same thing for the tie beams. Select beam, click inside this box, select one of the tie beams. I want to be sure I'm selecting the tie beam. Okay, so that I don't select per line. All right, this is it. Then select similar by cross section. Click this box here, then apply. All right, so that's all. Now, the next phase now. I hope you are getting it.
Yeah.
So the next phase now, we can close this now. So the next phase now, we need to group the members, because the Autodesk robot is going to optimize our design. It's going to give us the safest section. It's also going to give us the most economical section. Are you getting it now? Because all the sections we selected initially, they are just assumed. So now we go to groups. So we click on new, that's new group. That's group 1 now. Now we start with a name. Let's start with column. Set column underscore OPT, that is optimized column. That is, we want to optimize the column sections. You can name it anything. I'm just using OPT. In your own case, you might say COL, maybe. That's column. It depends on what you want. Then the member list. To get a member list, you just click on one of the columns. Sorry. Click on one of the columns. Then you right click and go to select similar by cross section. And everything is selected. You click inside this box. Every bar number is highlighted. Then you Control C now. Then you come back to this box. Then you Control V to paste the members. Is that clear?
Yeah.
All right. So you can click. Sorry, let's do it again. Select similar by cross section. Control C. Then here, Control V. Now after that, you go to sections. sections. Now, this is where you are going to, we want to optimize the columns. So now, you can either select the initial group that you selected, maybe that's simple cat pro, or you can go for UK section if you like. But let's go for the same simple cat pro, then we go with the HEA. We are working with the European standard, that's HEA section. Okay, so we go with HEA. Once you click HEA, you will have all the sections under HEA, that's from 100 to 1000. So robot will select the best one out of this.
Okay.
Okay, so once you are done, you click on OK. Then you save. Click on save. If you don't click on save, it will not save everything you have done. You click on save. So now we are done with the column. So let's do the rafter. So before you do that, you need to delete everything you have here. Okay. Then you click on the delete this now. All right, so we go with that's the next group now. We go to new. Sorry. New. That's another group now. The first group is the column.
One.
Then the next group now. So we need to delete what we have here. Then you can call it maybe a rafter. But then we need to first of all remove all this. Then we call it what? Rafter.
Yeah.
Now for the list now, we can click on one. We click on one, right click and say select similar by cross section. Then you click inside this box, everything is highlighted, Control C, then Control V. Can you see this now? Then you click on sections again. We are working with HEB. Simple Cast Pro, then you click on HEB. Then you have it listed HEB 100 to HEB 1000. Then you click on OK, then you save. Save. We have two groups. So let's work with the rafters and the columns for now. So now we are done with the grouping. Okay. The first group, we have the column. Second group, we have the rafters. All right.
Rafter.
So now we go for the code group design. Code group design. You want to know the sections that will fly for the rafters and the columns. Okay. So now we click on list. When you click on the list, you will see the group.
Okay.
That's a column. You press the control key on your keyboard, then you click on the rafter as well. So you have these two groups. Then you click on this double arrow. That's group 1 and group 2. Then you close this and you have the group listed here, 1 and 2. Is that clear? Yes. Now, the next thing is to click on optimization. And you go for the options. You can optimize by weight, or you can, if you have some preferences, maybe the maximum section height that you want, you can put it here. Okay. Maximum section height, minimum section height that you want, maximum flange width, minimum flange width, all those things. You can put it here, and robot will select sections within that range. Okay. Well, I don't go for this most times. I usually go for the optimization by weight. Okay. Then once you select weight, then you click OK. Then after that, if you want to save your calculation sheet, your calculation result, you can check this box. But for now, we are still checking, so we don't need to just uncheck. When we are ready to save the calculation sheet, we can click this one. For now, we just want to check whether the sections we have selected is okay or not. Okay. So now we click on calculation. The calculation is running. Very good. Now look at what we have now. What does this mean? We have 3 different sections here for the column and 3 different sections here for the rafter. The first one, if you click the first one that is showing red, you can see the ratio. Utilization ratio is 1.33. This is above 1. Every time your ratio must not be too close to 1. And it must not go above 1. Once it goes above 1, that's failure. You can see red already. So that means this section 220 cannot work. If you click on it, you will see incorrect section. Can you see? That means this section is not sufficient. Though it might be sufficient for some columns because the loadings on the columns differ.
It differs, okay.
But as a group now, because we are putting everything together as a group, this section cannot work for the columns. Though we still get to the stage when you will have to do it individually.